Hey YouTube, it's Ken Larson. Glad you're back here with me at the Tinker Bench. Today I'm smoking my vintage Bulldog. It's a GLC, and in it I have some W.O. Larson 1864. It's pretty good. Their 150-year anniversary blend. I don't think I care for it quite as much as the 2014 that they released this last year. I want to show you this tenon cutting tool. That's what we're going to be talking about today. This is the tool that you're going to need to produce a tenon on a Vulcanite stem if you don't have a lathe. I'm assuming if you already have a lathe and it's large enough to put a pipe stem through it that you probably don't need my help. This is a pretty simple tool. There's a drawbar runs across here, and it moves the cutter in and out, and it revolves around a central pin that goes down inside of the pipe stem. So we're going to go to the overhead view in just a minute, and I'll explain to you the different parts and how the adjustment screws work and hold it together and allow you to make those adjustments to tune it the way that you need it to fit, match your drill bit and the stock that you've got. So we'll do that in a minute. The tool that I'm going to talk about today came from the Pipe Maker's Emporium. So any dimensions that I give are going to be specific to that tool. There's a couple of these tools out there, they're almost identical. And the instructions are going to be pretty general, so it's not going to matter much, although there may be slight construction details that might not be exactly the same in the way that the designer has put the tool together. The tools basically work pretty much the same. Whether or not tolerances on one are tighter than another, I couldn't tell you because this is the only one that I own. If I had them side by side, I could maybe tell you and help you with that, but I don't have them, so I can't do that. I can only report to you how this one works for me and what I've found that does or doesn't work as far as ease of setting it up and repeatability. Last time you saw this block, I was working on it, scraping it down and forming the button shape. Now it's wrapped with electrical tape, and it's been sitting around the shop for a while collecting some dust. I can't really show you this end, or we can't work on this end because it's already done. Done with this tool. This tool has a single carbide cutter that revolves around a central axis that is in the center of this guide pin. So as this thing spins around, it shaves some of the material off. Stems like this, quite a bit of material has to come down. Usually a pipe tenon is 5/16 of an inch in diameter, and the length is variable depending upon how deep you drill the mortise, and you can adjust one or the other. When you get these stems, they're quite unfinished, and you can see the mold lines on all of them. These I've already
opened up on the end, and I wish I had one to show you that hasn't already been opened up a little bit. But this central guide pin has to ride down inside of here. They're not always manufactured completely perfect. You saw this before. Rides in there pretty well, actually. An 1/8 inch drill bit, 128 thousandths is what you want to use, and it has to go in deep enough in order to accommodate the full length of this guide pin here. So you're looking at something about like that. You can pretty reliably take a Dremel or some sort of a flexible shaft tool and install your drill bit and then run it by hand up into there. As you know, the size of your tenon is going to be critical, otherwise it's going to have a really sloppy fit inside of the pipe, and you're going to be starting over, or you're going to be doing this 2 or 3 times, and it's going to be real frustrating for you. If you are patient and work with this tool, you will have some pretty good degree of success, although it's not a perfect design. I've got to say that from the beginning. I'm going to give you some dimensions. Let's do that first. First of all, you need to open this up so that that guide pin can run true down the center of there. It's going to be really, really close. But if you run this tool in there and you haven't cleaned it up first, and you know that it's got 128 thousandths or an 1/8 of an inch right there, once this heats up, either or both, you're going to find some binding in there and you're not going to be happy. It's going to scorch this, and it's going to cause this to get hot. You're just not going to want to do it. This tool comes with a set of Allen wrenches. Smallest one here is to change the cutter. You can take this cutter, obviously move it 3 times, and refreshen the edge. The center pin here, you can actually take it out. It's secured with a longer set screw in the group. This is a 1/4 inch, and this is an 1/8 inch, 0.128. It's got to go inside easily for the full depth. The depth of this pin on this particular one is 1 5/16 inches in length. So that set screw on the side locks the guide pin in, and if you take it completely apart, it'll have the longer Allen bolts in there. The cutter movement itself moves in and out with this drawbar, but it's locked in place in 2 different positions. It's locked in place here, and it's locked in place here. The one on the bottom goes into the notch in the drawbar and prevents it from moving too far. It allows it to move in and out. The one from this side pushes against the side of the cutter bar and helps lock it into place, and this is going to move the cutter bar either closer or further to the guide pin. It works opposite that you might expect. As you tighten this, the tenon is going to get bigger. As you turn it left, which you would normally think is looser, the tenon is going to get smaller. It's easy to get confused when you're making adjustments, especially if you've got it upside down in your drill press. Keep that in mind. Here's a profile of your factory-made stem. This right here, draw a hole. Point 128. Assuming you're going to make this cut 5/16, right here you want to be 0.312, and this is the maximum depth that you can cut, but you have to cut past this point, otherwise you don't get that nice crisp shoulder. So the length from here to here on this particular cutter is 0.660. So I'm going to start at a point here. I'm going to trim some off of here. This is where you're going to take your waste material out of. So if you've got 0.312 less 0.128, you're going to get 184 thousandths. Divide by 2, you get 92. Wall thickness here to here should be 0.092. Knowing that, you'll be able to measure between here and get fairly close. The reason that I'm telling you this is because this tool is not that easy to set up. It has a lot of movement once you start working with it, and you find that it just doesn't have a really good kind of a keyway system in it. Alright, so that's going to get you pretty close. You know that gap right there mathematically should be 0.92. I would be a little bit generous with the material that you're going to leave on there, just because you can't put it back. So going to need a precision measuring device. I like vernier caliper. Going to bring it in here and make the adjustments across here. Here's the problem that I was talking about. You see how much that thing can move? Well, as you draw in on them from below and from the side, that gets better, but it only gets better a certain amount. It really never gets great. So the deal is, once you get this thing set up, you really don't want to unset it up. I know of guys that have purchased more than one of them so that they can leave one set right at 5/16 of an inch. They know it'll give them a perfect cut all the time, and then another one that they can kind of screw around with. What I'm doing here, this is going to get me close. I'm not going to be right on it. And then I'm going to compare it and actually make a real shallow cut on the end of a stem before I commit anything really dire to it. Kind of hard to trying to hold this so that you can see what I'm doing while I'm doing it at the same time. And you can see that it's a little difficult to get it really right on the mark. So I know that I'm a little bit oversized right there, just a little. So I'm going to go ahead and tighten it down. This one tightens the center bar. This one pinches the drawbar from the bottom. And this one pinches it from the side. Before I committed this to something that I really cared about, I would test it. You can turn this by hand and get it to start cutting. Once you get it to start cutting, you can usually get a pretty good cut all the way around, and check your diameter before you ever put this thing in the drill press. I like the drill press. I think it's the most accurate. I think it follows along the best. 5/16 is 0.312. So we want to get enough of a cut on there to where we can be pretty close. I've got 0.3 to almost 0.330. So I'll be able to tighten it up just a little bit. But you can repeatedly try it and get to where you're real close. It's up to you how close you want to get to 5/16. Be aware that whatever you do here should match the drill bit that you are using. Not all drill bits are going to be exact, and so I would measure and check everything before I committed myself too far on this. But once you've got this set up and you're happy with the cut that you're going to get, the diameter of the cut that you're going to get, well, that's pretty close. It's just a hair over. So you can take that last little bit off by hand, or you can risk it and get on down there. This thing's pretty aggressive. It'll take this off even though this is a fairly thick cut. You can see that on something like this. Take it and you swing this around. That the cut on one here would be 1/8 of an inch on that one. Be a bit more on one of these 3/4 of an inch diameter stems. So that's the basics of setting that up and how this thing moves in and out. Next, you need to figure out how you're going to hold this piece and how you're going to turn the cutter. Real important. I have seen some things that are pretty scary out there, and I'm not going to recommend them to you. You can probably imagine the sort of thing that I'm talking about, but you want to have both pieces rigidly mounted before you go about doing this. Trying to freehand that down through there, not a good idea. I wouldn't even try it.